In our first problem, we had a 300 gram mass on an incline of 37 degrees. Now, I'm just going to draw a small schematic of the way we would start. We would take whatever it is that represents our mass and put it on the incline. And one thing we know is we have the force of gravity acting vertically downward. The decision we have to make, and if you're dealing with an incline, you pretty much always need to make the same decision, but you need to understand why you make that decision so you'll be able to use this sort of reasoning in other situations. Everybody wants to use a coordinate system that goes this way and this way, vertical and horizontal, so that the gravitational force will be straight down. Well, quite often, for example, in the case of projectiles, that's exactly where you want gravity to be. You don't want to have to worry about components of gravity parallel to two different axes. You want all the gravity on one axis when you're dealing with a projectile, and that way your y motion is characterized by uniform acceleration and your x motion for the ideal projectile by uniform velocity. And that makes the analysis much simpler. Now, in the same way, the correct choice of coordinate system, or the most convenient choice of coordinate systems here, makes the analysis much, much simpler. Okay, well, so what do? We orient our coordinate system so that the x-axis is parallel to the incline. And that way we know that our motion is all going to be in the x direction, as long as the object remains on the incline. Now, if the object leaves the incline, or the incline collapses, well, it's all out the window. You're not going to model it the way we're going to do here. So we're assuming we have an intact and strong enough incline that doesn't bend under the load or doesn't collapse or anything, remains rigid, and that the object isn't propelled up off of the incline by some force. Okay? Because in that case, the y-axis, being perpendicular to the x, will be perpendicular to the incline, and there's no motion in the y direction. It's all in the x direction. So you've simplified everything by the fact that there's no motion in the y direction, meaning, of course, that there's zero velocity in the y direction, and clearly zero acceleration in the y direction. And that tells you that the sum of all forces acting in the y direction have to be zero, because the acceleration in the y direction is equal to the net force divided by the mass. Okay? If the net force has no component in the y direction, if the acceleration has no component in the y direction, then the net force could not have had a non-zero component in the y direction. So we have equilibrium in the y direction. The x direction, well, that's up for grabs. Sometimes we might have equilibrium in the x direction. Other times we might have uniformly accelerated or even uniformly accelerated motion in the x direction, depending on what kind of other forces are present. So the basic idea is, one thing you want to take away is, if you've got an incline, the x-axis is parallel to the incline. The thing you really want to take away is why, because then you have equilibrium in the y direction. All the motion is in the x direction. Okay, well, now that's the very first thing you have to understand about having a mass on an incline.